Okay, in this video what we're going to look at is beginning this process of completing the square. So we keep saying completing the square, and what I want to bring up is the fact that what we mean by square is that we have this, in the first video, set of perfect square trinomials that factor down always into just a square of a binomial. And the advantage to having a square of a binomial is that we're able to use square roots to solve it. So in any of these instances here, we can see that they were already perfect square trinomials. And all of these instances here, what I'm going to show you is that we have some, I guess, trinomial in standard form. So we have some ax squared plus bx plus c. But what I want to do is I want to force something in standard form here to become a perfect squared trinomial so that I can actually just write it as the square of a binomial. This is what I desire. Okay? So in order to achieve this, I'm going to lay down some ground rules here, but what we're going to do is we're going to recognize, first of all, that this trinomial here must have an a value of 1. Has to have an a value of 1. But if that is the case, that we have some x squared plus bx plus c, then the requirement is this. If c equals this, b over 2 squared. Okay? In other words, it's half of middle term, comma, okay, because the order matters here, squared. If you take half of your middle term and square it, and you make that the value of your c here, then what happens then is we get this factored expression over here on the right that I'm going to write as x plus b over 2 squared. And so here's going to be the deal. When we complete the square, what we're really doing is adding in a particular c value that turns it all of a sudden into a perfect square trinomial that would cause it to fold right down into this square of a binomial. So the key is going to be here this. We want to, if we have a trinomial where the a value is 1, add on half of b squared as our c value, and if we do this, then we'll be able to put this into a factored form. So what I wanted to do is just look through a few examples with you here, starting with this number 12 here. Basically, we have x squared plus 10x plus c. So first things first, let's recognize one thing here. Our b value here, our b value is 10 in this expression. So what we would write here for what we want for c is exactly what you saw me writing down here. We would say we want 10 split in half, and we're going to square it. So I'm going to ask you to actually write this as b over 2 squared, but we're going to simplify it here, and what we notice is we get 5 squared, which is 25. So what I'm going to do is I'm going to write on top of this x squared plus 10x plus, and I'm going to put a 25. The fact of the matter is, if I were to put that 25, notice this. All of a sudden, the first number is a square, the second number is a square, and the middle term is 2 times what I would square to get x and 25, which are x and 5. So if that's the case, and I add on a 25 here, all of a sudden, without even thinking about my factoring rules, what I can tell you is that you get this squared binomial. And inside of this squared binomial, it should be half of the middle term, that number that we squared to get the 25 in the first place, this guy, okay, this 10 halves, that's what's going to go in here. So I would say plus 10 over 2, which in this case is just 5. So notice, if we add on half of our middle term squared as this c value, then we have to factor down into this square of a binomial. So taking a look at these other ones here, we'll deal with them rather quickly. We would say that I've got x squared plus 20x. What would I really want to have here for c that would cause this to be a perfect square trinomial? So again, because our b value here is 20, we're going to say that this is 20 over 2 squared, which is the same as 10 squared, so we would get 100. And if we had x squared plus 20x plus 100, then all of a sudden we would get something that has to factor down into this. And again, what I would put right here is just half of our middle term. So half of a positive 20, I would put a positive 10. This would, of course, be very easy to check by foiling back out and seeing that you get this perfect square trinomial. So number 14 is a little bit different than 12 and 13 here. You'll notice that our middle term here is negative. So in this case, we're going to say b, as it is a negative 12, we're going to say that our c value here is really negative 12 halves squared. So we'll cut our middle term in half and square it. In this case, what I want you to recognize is that we're squaring a negative, which means we get a positive. As a matter of fact, when I rewrite this here, x squared minus 12x plus 36, if anything is ever a perfect square trinomial, because we're squaring whatever's inside these parentheses here, what we are going to acknowledge that our last term is always positive, if it's a perfect square trinomial. So in this case, now that I've forced this to be a 36, which is half of our middle term squared, notice again that I can factor this, and I would say, well, what belongs in here? It's always just going to be half of your middle term, which in this case, very importantly, is a -6. So this would be our factored form of this perfect square that we completed by adding on our 36 here. So let's complete the square down here, find out what we would want to add on for C, okay, in order to make these perfect square trinomials. And I'm actually going to change this. This should be number 22 here. And this shouldn't be a plus, but should be a minus. So in these cases here, the weird thing is this. Your B value is odd. And so when we say, well, what's half of 5 squared, I get a whole load of people that want to just give me a decimal and square it. But what I'm going to encourage you to do is just deal with a fraction. So when we say half of 5 squared, how would I write this? I would literally just say 5 over 2 squared, and we would go ahead and multiply 5 halves by 5 halves, which means we're really just going to take 5 squared, which is 25, and we're going to take 2 squared, and we're going to get 4. So if our original polynomial had been x squared plus 5x plus 25/4, then we would have had a perfect square trinomial, and this thing would have factored, therefore, into the square of a binomial. Most of the time I ask people, I say, hey, can you think of two numbers that multiply to be 25/4 that add up to be 5? Nobody can tell you that. But anybody that listened to a completing the square video can tell you that whatever goes in here is always just half of that middle term. So if my middle term is 5, then I'm going to say this is a positive 5 over 2. So my factored form is just x plus 5 halves squared. Likewise over here, I would say, well, my b value is -5. So my c value, what I would rather have here instead of just c, is a -5 over 2 squared. And what I want you to recognize again is if you square this value, you get 25/4, but it's explicitly positive because when you square a number, you only get positive results. So our original polynomial, if I rewrite this, would be x squared minus 5x plus 25/4 if it's a perfect square trinomial. And if it's a perfect square trinomial, which we caused to happen here, then what I would get in here is just half of my middle term. So I just take -5 over 2. So you can see the difference between these two problems here is not what we get as our c value that we added on to complete that square. It's more of what we get in here when we do factor it. So the idea is going to be, as long as you have a trinomial where your a value is 1, you can always add on half of your middle term squared as your constant value, and by doing so, you would force this to collapse down into a square of a binomial, which is extremely desirable, especially when you solve equations. Cheers.